Trees are the heaviest and largest living things on Earth, with the most massive tree weighing almost 2,000 tons, as much as 10 blue whales. But instead of floating weightlessly in the ocean, it reaches 25 stories into the sky, held in place by surprisingly shallow roots. You'd think trees grow from the ground because, well, they're made of stuff and there's stuff in the ground. But if something so massive and huge ate something down below, it would have to leave holes. Instead, trees are growing by literally eating thin air. But this is only half of the story, because down in the ground, roots are mining rocks in ways weirder than you can imagine. How does this work? How to eat air to grow huge. Carbon is the most valuable material for living things. A chemical multi-tool you can make almost everything from, and a good amount of it just floats around in the air and the oceans. What makes plants so incredibly successful is that over 1 billion years ago, their ancestors became better than any other living thing at harvesting carbon. They used it to grow and grow and grow. Today, plants make up 80% of the biomass on Earth and are the basis for all complex life. All animals eat either plants or animals that eat plants to get the carbon they need. Trees are an especially ingenious way plants found to harvest massive amounts of carbon. Trees are big and heavy, so they need a lot of material, but the atmosphere is only about 0.04% CO2, 425 CO2 molecules per million molecules in the air. To get a single ton of carbon, a tree has to process 6,000 tons or 5 million cubic meters of air. This is a lot. So trees developed sophisticated biological industrial megalopolises, their crowns. A huge industrial park network made from dozens of branches, sub-branches, and hundreds of thousands of twigs that can sense the sun and shape the tree to grow towards it in slow motion. They're carrying up to 1 million leaves, the industrial parks where a tree eats and builds, consuming extreme amounts of resources from the air and fed by the roots down below while vomiting waste and changing the climate around them. Let's zoom into a single leaf. It's made from hundreds of millions of factory cells and optimized to have as much surface area and be as thin as possible to harvest sunlight. While your skin is hundreds of cells thick, a leaf can be just 10 cells top to bottom. On their top, leaves have only a single ultra-thin layer of protective transparent skin cells that let light through and keep water in. Below them are layers of factory cells, filled to the brink with chloroplasts that do the actual work. Beneath them, a spongy layer of loose cells enables gases to travel around. The whole leaf is traversed by a network of vein-like superhighways that carry sugars back down and bring water and minerals up from the roots. At the bottom is another protective layer of cells interrupted by hundreds of thousands of stomata, tiny mouths opened and closed by 2 guard cells that look a bit like lips. Each day, an adult tree pulls up dozens of liters of water all the way from its roots in the ground to these veins, where about 95% of it is sweated out through hundreds of billions of these tiny mouths. This cools the leaf factories, which need to stay in direct sunlight as long as possible, and the air around the tree. And it surrounds the tree with an invisible mist. The vapor from a forest of billions of trees can seed clouds and create rain. Rainforest is literal. Without the trees, the Amazon would be a sad, dry shrubland or desert. The other 5% of the water is used to keep the cells alive and to power the factories where the magic happens, photosynthesis. We're not going to explain the details here, but in a nutshell, with the energy from the sun, water molecules are split into hydrogen and oxygen. The oxygen is ejected, while the leftover hydrogen and CO2 are forged and reduced into glucose, a simple sugar that's both battery and building block, and the source of most carbon in the world for most animals. Oxygen is not just garbage to the tree, though. To actually use the energy stored in the glucose, the tree has to burn the sugar, just like we humans do, with cellular respiration. So, all living cells in the tree suck in oxygen through the tiny leaf mouths, cracks in the bark, and even root tips tapping into tiny air pockets hidden in the soil. This respiration runs non-stop, and especially at night when the leaf factories stop production. Trees actually reabsorb some of the oxygen they produce and almost all of the rest gets used up by microbes and everything else breathing nearby. Most of the world's free oxygen doesn't come from trees, but from algae and cyanobacteria in the oceans. But this is only half of the story, because the even more insane parts of trees are the second invisible crown, the underground empire of the roots. Most of the water a tree needs comes from rainfall, which soaks mainly into the upper layers of soil. Annoyingly for trees, their crowns are big umbrellas, so their roots need to spread out far and wide towards the side. About 50% of their roots are packed into the top 25 centimeters of soil. They're not a mirror image of the crown, but a dense, tangled mat deeply intermingled with their neighbors. Only if it's very dry do roots grow straight down to tap hidden water reserves, in extreme cases more than 20 stories deep. But this is a rare exception. Most roots reach down 7 meters. But roots have a far